Good morning, Sanibona. Welcome to this presentation on similar triangles. Two triangles are similar if two angles of one triangle equals two angles of another triangle. So that's the meaning of similar. So two triangles are similar if two angles of one triangle equals two angles of another triangle. So here you can see the white triangle and here you can see the green triangle. This is triangle PQR and that is triangle ABC. So if we compare it, and we just take that out, you can see that angle A is equal to angle P. You can see angle B is equal to angle Q. And you can see that angle R is equal to angle C. So these two triangles are similar. So we can say triangle PQR is similar to triangle. Now, that's a symbol for similar. That's a symbol for similar. Triangle PQR is similar to triangle. Now, the second one, just like congruency, when you label the second one, you got to label very carefully. So when I said PQR, I went from X to Y to Z. I'm looking at the angles, you see. So in the next diagram, I must go from X to Y to Z. So it will be ACB. ACB. Of course, you can start any way you like. Somebody else might start here. They may say RPQ. Triangle RPQ is similar to triangle. Now, when this person said RPQ, he went ZXY. So you must go here ZXY, which will be BAC. And another student can say that triangle QPR, he'll start here, QPR. So that's YXZ. So when I go there, I must go YXZ. So it will be triangle CAB. So you can label whichever way you like, but you must follow the order. You must follow the order. So when we said PQR, we went X, Y, Z. So then here we have to go X, Y, Z. That's why we said ACB. All right. And after this, you always write angle, angle, angle. We say that the triangles are equiangular. Equiangular. Equiangular means all the angles are equal. Equiangular triangles. But the main word for describing these kinds of triangles, is similar triangles. Similar triangles. This is just an adjective for the angles. Because the angles are equal, we say they are equiangular. Right. So let's see how we prove two triangles are similar. So we're now going to prove those triangles are similar to one another. You do the proof just like congruency. So we're going to prove them similar to one another. So I'm going to move over there. Right. Required to prove triangle ABC is similar. Now, I just labeled it ABC. When I labeled ABC, I actually moved from X to 36 to the last angle. So in that triangle, I must also move from X to 36 to the last. So here I moved x 36 blank, x 36 blank, so it will be PQR. PQR. Proof. 1. Angle A is equal to angle P. The reason is it is given. Number 2. Angle B. Remember, we're looking at this triangle and then we're looking at that triangle. Angle B is equal to angle Q. Reason, it was also given. It will not always be given. Sometimes you'll have to find out for yourself. But so number 3, angle C will automatically equal to angle R. And for that you will say remaining angles are equal. Because this angle here is actually 180 degrees minus x minus 36 degrees. And this angle here is also 180 degrees minus x minus 36 degrees. So the remaining angles will always be equal as long as the first two angles are equal. If these two are equal to those two, then the remaining angles will be equal. Then finally, triangle ABC is similar to triangle PQR. Now, in similar triangles, when you finish prove them similar, you have to make a proportion. You have to build a proportion or write a proportion after this. So now we're going to write the proportion. So how do you find the proportion? You do this. You take the first two. You take the first two and you put it on the first two. Then you take the second two, you put it on the second two, and then you take the first and the last and you put it on the first to the last. So that's how you build a proportion. So you take the first two, which is AB. AB over PQ will equal BC, the second two, over the second two, QR, which will be over the first to the third, AC, over first to the third, PR. So that's called a proportion. That's called a proportion. So you will always build your proportion. Alright, so first thing, after you proved it similar, build your proportion. Okay. Now later on, you might want to use this proportion. When you want to use the proportion, you always use it at two at a time. What I mean by two at a time. From that, you can now say, therefore, AB over PQ, this first two is equal to BC over QR. Or you can say the first one, AB over PQ is equal to the last one, AC over PR. Or you can say that the second one, BC over QR, is equal to the last one, AC over PR. So, I'll repeat that. Once you build the proportion, you need to break them up two at a time. You need to break them up two at a time, because when you want to do calculations later on, then you need a proportion like this with just two fractions. Here we have a proportion of three fractions. You can't work with it three at a time. You can only work with it two at a time. But first you build that, then you write this. So you take the first one, AB over PQ is equal to the second one, BC over QR. So that's how we got that. Then, still with the first one, AB over PQ, it'll be equal to the third one, AC over PR. And then finally, the second one, BC over QR, is equal to AC over PR. There's no other combinations. So you've got that. So that's our first video on similar triangles. You must be able to prove them, build a proportion in full, and then separate them into two fractions at a time. Alright, we're going to stop there and we're going to do a few more examples. Now remember, in this example everything was given. So we will do an example just now where we have to prove two triangles similar and all the angles will not be given to us, and we will try to find the missing angle and then prove it similar. Alright, we will stop here.